Okay, what we want to do, I just want to say a couple of words briefly on Newton's first law of motion. So this is Newton's first law of motion, and that is the law of inertia. Inertia. So what is this concept of inertia? Well, you could think of inertia as a tendency of something to stay in motion if it's in motion, or the tendency to something to stay at rest if it's at rest. So what does this mean? Well, let's just illustrate this with a little concept here. Let's say we got a huge boulder sitting on the ground. Very massive boulder. It's large and it's massive, and it's sitting there doing nothing, and it's not moving, it's just sitting on the ground. Inertia has to do, the object's inertia, the boulder's inertia, has to do with how easy or how rather difficult it would be in order to get it into motion. In other words, to change its state from a state of rest into a state of motion, you're going to have to apply a net force to the boulder to get it to move. And the force that's going to have to be applied, this net force, is going to have to be very large if the rock is very massive. So this rock here, this big boulder, is said to have a very great inertia. In other words, it has a very, very large mass, and therefore it's going to be difficult, if it's at rest, to get it moving. You're going to have to exert a large net force, so it has a great inertia. So right away we can see that inertia has a correlation or relationship to the mass of the object. Now if we have a smaller object, let's say we have a small rock here, this has a small inertial property. Small inertia. Why is that? Well, if it's at rest, in order to get it moving, the net force that I have to apply to the smaller rock is much, much smaller. So this force here is very much, much smaller than this force here. So the smaller the object, the less massive the object, or the smaller the masses of the object, the less inertia the object is said to possess. Okay, inertia is linked to mass, and this is what I want you to remember. That inertia is directly related to the mass of the object. So if you have a large, massive object, it's going to take a larger force to get it to move from a state of rest than a smaller, less massive object. Now suppose something's already moving. Suppose something's already moving. And we got something in motion. So let's just say, let's talk about something in outer space. Let's say we have a meteor. Here it is in outer space, and it's moving through space with a very large velocity. I don't know, let's just say 500 meters per second right now. It's going through space, and there's no air. No molecules in space, no air molecules. There's nothing to slow this rock down. So the rock experiences no net force. So let's say there is no net force acting on the rock or the meteor. If there's no net force acting on the meteor, then it'll keep going forever. And its inertial state is a tendency of this meteor here to want to keep going at a constant velocity. So this will be constant, won't change, of 500 meters per second, and it'll do that until something acts on it to slow it down. Could that be? Well, suppose it's going along this way. Here it is, moving along at a constant speed, constant velocity, 500 meters per second. There's no net force acting on it. It's going to continue to do that forever until it comes across some larger object in space and that larger object slams into it, and it creates a force that way on the meteor, and that's the end of the meteor. Okay, so it stops it finally. But you see, it took an external force to actually change the velocity of this object. And that, again, is a property of inertia, that once something's moving and it's in a state of motion, it wants to stay. Say, draw something here, it's moving. And this is its velocity v. It wants to stay with a constant velocity. It doesn't want to slow down. It doesn't want to speed up. It wants to keep going at a constant velocity without changing its direction until some net force acts on it. And so that's the concept of inertia. Something that's moving wants to keep on moving at a constant velocity, doesn't want to slow down, doesn't want to speed up. It'll keep going at a constant velocity until some net force acts on it. Something's got to either push it or pull it, net force, okay, in order for it to change its velocity. So that's the concept of inertia. It also, if it's objects at rest, it's going to want to stay at rest, and it will stay at rest until some net force is applied to it. And it's in relationship to the mass. So we'll talk a little bit more about this as we go on a little bit later.